All right, so section 8.2 talks about equals, relation, and equations. Okay, so what I have here on this page is the properties of equality. Okay, there's something called the reflexive property of equality, and it just says the number A is equal to the number A, right? So 3 equals 3, negative 8 equals negative 8, x equals x. Okay, there's something called the reflexive, property of equality, and it just says if A equals B, then B is equal to A. Okay, and I'm sorry, the first one was reflexive. This is the symmetric. Okay, and then we have the transitive property of equality, and it says if A equals B, and then if B is equal to C, well then A and C are also going to be equal to each other. Okay, and that's what we have right here, simply written out. Reflexive property is A equals A. Symmetric is if A equals B, then B equals A. And then the transitive property says if A is equal to B and B is equal to C, then A and C are also going to be the same. Okay. All right. And so we have addition and multiplication properties of equality here. And so it says, if A equals B, then A plus C is equal to B plus C. And if A is equal to B, then A times C is equal to B times C. Let's see. And then cancellation properties. So if A plus C equals B plus C, then A equals B. And if C is not 0, if AC equals BC, then A and B have to be the same. And then there's something called the zero product property. And it just says if A times B is equal to 0, let me get my pen to work again. Sometimes it does. There we go. If A times B is equal to 0, then at least one of them, A times B, must be equal to 0. Okay, so what we're going to do here, we're just going to solve a few equations, okay? And these are problems that are similar to what you're going to see in your homework. So remember what we're trying to do. When we're trying to solve an equation, we're trying to get the letter x by itself, right? Okay. So a lot of times in doing these problems, guys, where my equal sign is, I like to draw a line going down, and this lets me know that I have things on the left side and I have things on the right side, okay? So the first thing is we want to get all the x's on one side. What side do we put them on? It really doesn't make any difference, okay? Whether we put them on the left or what we put them on the right, it doesn't matter. We just have to make a decision. Right now I'm going to decide, let's put all the x's on the left, okay? So I want this x right here to move to the other side. So if it's a minus x, I'm going to do the opposite of minus, which is 2 plus. Okay, and again, I know you guys have taken college algebra, so this is probably a problem that you would possibly, hopefully know how to do, but in case you don't, we're going to do it together. So remember, x plus another x is a 2x plus 3. This is still equals the number 2, and those x's canceled out, right? We're cancellation property. Okay. So remember what we said. I decided I'm going to put all my x's on the left. If my x's are going on the left, then my numbers need to go to the right. So I need to move this plus 3 over. So I'm going to go minus 3, and I'll write over here, we'll have a little bit more room. 2x equals 2 minus 3. Think of a 2 positive as how much money you have, and negative is how much money you owe. You have $2, but you owe 3, ¿sabes qué? In English, you know what? You still owe 1. So it's a negative 1. Then we can divide both sides by 2. So we do that. And we get x equals negative 1/2. Okay. All right. Let's do the same thing for the next problem. Okay. First I'm going to do, draw my line all the way down. Remember what we have, the left side and the right side. Okay. I'm going to do the same thing I did before. I'm going to say I'm going to put all my x's on the left side. So the first thing I'm going to do is I'm going to say, let me minus this x here, and let me minus this x over here. So I'm actually going to write it out. I'm going to put 3 over 2 with an x, minus, now I know the number in front of that x is a negative 1, but I'm going to think of that negative 1 as minus 2 over 2 with an x, minus 3 is equal to 2. Now the reason 2 over 2, remember, it's the same thing as 1, right? I wanted to do that so that I would now have a common denominator, okay? So the denominators stay the same. 3 minus 2 gives me a 1. X. It's a minus 3, Omar, not a plus 3. So put a minus 3 right here. Okay, there we go. Equals 2. Now remember what I said. If I'm moving my letters to the left, I'm going to put my numbers on the right. So now I'm going to go plus 3, plus 3. Okay. Right over here where I got some room, 1/2 x equals 2 plus 3 I know is 5. Okay. Now I want to get rid of that 1/2 that's in front of my x. Since this number here is a fraction, the way I get rid of a fraction is I'm going to multiply by the reciprocal. Remember, the reciprocal means let's multiply everything by 2 over 1. So if I'm multiplying by 2 over 1 here, I'm going to multiply by 2 over 1 over here. But hold on, I want you to think about this for a minute. Isn't 2 over 1 the same thing as 2? So let's not put the 1 there. Let's keep it here though, okay? The reason I'm going to keep it here, I'm going to show you what happens if we go straight across. That becomes 2 over 2 with an x is equal to, I know 5 times 2 is 10, but remember what we said 2 divided by 2 is? Isn't 2 divided by 2 just the number 1? And that's a 1x equals 10. Okay. All right, so you can see we got a few more here. Let's do them together. We're going to go in pieces. First thing I'm going to do, draw my line. Remember, left side, right side. Okay. So we got some parentheses here. So we're going to deal with that first. So I know 5 times 2x is a 10x. 5 times the square root of 2, don't get nervous, guys. It's just 5 squared, it's a 2. Okay, notice the 5 doesn't have a square root, so it stayed on the outside. Okay. 7 times 2x, I know, is 14x. 7 times 2, again, since the 7 doesn't have a square root, stays on the outside. Okay. Equals 12 square roots of 2. Okay. So now let's go ahead and combine our pieces. 10 plus 14 is a 24x. Now these are also like terms. So when I'm adding terms like this, the fact that they're both square roots of 2 just says you're going to put a square root of 2, and then we're just going to add the numbers in front. 5 plus 7 is 12. Okay. Equals 12 square root of 2. Now, since I put all my letters on the left, my number is going to go to the right. I'm going to move this guy. Let's move him over here. Okay. And notice what happens. We get 24x. Those cancel. 12 minus 12 gives me 0 because they cancel. So when I divide by 24, we just get x equals 0. Okay. Alrighty. So let's continue with this here. 1, 2. So 3x minus 9 equals 5x minus 15. Okay. Remember we said left side, right side. Okay. Now remember what I told you. It doesn't make any difference what side we put things on, right? It didn't make any difference. And so we noticed in the last couple of problems, I was putting the x on the left, right? What happens if I move it to the right? It's going to be the same thing. So look, if I move the 3x this way, now guys, I'm not doing this to confuse you, okay? So I don't want you to think like, why is Omar doing that? We were doing it one way. Why are we doing it different now? I just want to show you that which way you decide, you're always going to get an answer, okay? So look, those 3x's cancel. 5 minus 3 gives me the 2x. Here's my minus 15, okay? So if I'm putting my letters on the left, then my numbers, if I'm putting my letters on the right, then my numbers need to go to the left. So I'm going to say, let me go plus 15. Let me go plus 15, okay? So negative 9 plus 15, remember, think about it this way. I have $15, I owe you 9. I'm left with 6, okay? So when I divide both sides by 2, I get 3 equals x. Remember we talked about that symmetric property? 3 equals x is really the same thing as x equals 3. Okay. All right. So this next problem here, you might remember this from college algebra. If you don't worry. I'm going to show you how we're going to do it. And so the first thing I'm going to do is, this problem has a square. Okay, so let me, number one, get my line going down the middle. Because it has a square, the first thing I'm going to do to get rid of that square is I'm going to take the square root. Okay. Now remember what we said the square root means. The square root means I'm getting pairs. Well, I want you to notice, look what I have. I have a 2. That means that there's a pair of whatever I have on the inside. X minus 2. Now, with square roots, I want you to think about square roots. So this is kind of just like I'm going to kind of do it over here so that I have a little bit of room. So I just want you to think about this for a minute. So I'm going to put it right here, like, hold on. This is a pause, okay? When I'm taking the square root of 9, right? Come on, pen, don't give me no problems right now. Just because I said pause. Okay. When I'm taking the square root of 9, right, I'm asking myself, what number, I'm going to put it here, what number, when I square it, gives me the number 9, right? So you might say, well, look, it's 3. Yeah, look, 3 squared gives me 9. But wouldn't the number negative 3 squared also give me 9? Remember what negative 3 squared means? It means negative 3 times another negative 3, which is also 9, right? So that's why when we take that square root, we put that plus and minus, because every number is really going to have 2 square roots, okay? Pause, right? Not this pause, but that pause, right? Y'all want to hear a quick joke? 3-legged dog walks into a bar and says, I'm looking for the man who shot my paw. Yeah, quack quacks. Okay, so let's see. So I'm going to get plus, oops, come on, pen. Oh, that's what happens, Omar, when you tell a bad joke. This thing freezes up. Let's see. Oh, hold on, guys. Let me pause this again so I can get my thing. Okay, so here I'm going to get plus and minus 3. All right, all this means is that I'm going to have, let's make sure this is working right here. Yes, it is. Okay. All this means is I'm going to have 2 equations, okay? One of them is going to be x minus 2 equals 3. The other one's going to be x minus 2 equals negative 3. Okay? So we're going to add 2 to both sides. 3 plus 2 is 5. That's my first answer. We're going to add 2 to both sides. Negative 3 plus 2. Negative 1 is going to give me my second answer, okay? All right, so let's scroll a little bit more. And let's see what we got for the next problem here. And it says, for a particular event, 788 tickets were sold for a total of $5,260. If students paid $5 a ticket and non-students paid $8 a ticket, how many student tickets were sold? Oh, I don't really know. Let's see if we can't figure this out. Come on, pen, don't give me problems anymore. Hold on, guys. Sorry about that. Okay, so now we're back in business. Let's see. So let's say S will be my student tickets. Okay? And let's say N will be the non-student tickets. Okay? So S plus N, how many tickets did we sell total? We sold a total of 788 of them. Okay? Now, what else do we know? We know that students paid $5. So 5 times S. Non-students paid $8. 8 times N is going to give me 5,260. Okay? So let me move this over a little bit. What I'm going to do now, guys, this is a system of equations. Again, you probably saw this in college algebra. But I'm going to show you how we're going to do this. I'm going to say, look, let's solve this equation for the letter N. Let's bring this S to that side. Now, when we do that, that S changes signs. It becomes a negative S. Okay? Now what I'm going to do is I'm going to take this value of N here and I'm going to plug it in over there. Okay? So let me come back and let's say something like 5S plus 8 times 788 minus S is equal to 5260. Okay? So 5s. I'm going to grab my calculator real quick like. Let me see. Let me move it this way. What am I multiplying? I am multiplying 8 times 788. That's equal to 6304. 6304 minus 8s equals 5260. Okay. Let's combine those together. 5 minus 8 would be a negative 3, right? Because I have $5 and I owe you 8. Plus 6304 equals 5260. Now let me minus my 6304 on both sides. So that's going to leave me with a negative 3s equals, I'm going to grab my calculator again. Let me move it this way. What am I subtracting? 5260 minus 6304. That gave me a negative 1044. And all we need to do now is divide both sides by negative 3. Okay. So let's divide it by negative 3. And S is 348. Now remember what S stood for? Oops, sorry. Let's come back here. Whoop, that's not what I wanted to do. Sorry, guys. Let's bring this down. Let's bring this down. Let's bring that down. Bring that down because we don't need to come back to this. Here we go. Okay. The question was asking me to find how many student tickets were sold, and we found that to be 348, right? Now, it didn't particularly ask me this, but suppose it would have said, can we also find how many non-student tickets were sold? And if it was asking us to find that, we could do that pretty easy. Do you remember how many tickets we sold total? We sold a total of 788, right? So if we took 788 minus 348, we'd end up with 440. So the non-student tickets would have been 440. Okay, I know it didn't ask us that, but in case it did, that's how we would do it. Okay. Alrighty. Let's take a look at the next problem that I got here. It says a 5-foot board is cut into 3 pieces. 2 equal lengths one, and the third is 9 inches shorter than each of the other 2. If the cutting does not result in any length being lost, how long are the pieces? Okay, so I'll tell you what, let's do it like this. We got 3 pieces. Piece 1, piece 2, piece 3. Okay. Now it says 2 are going to be equal lengths. So suppose the first and the 2 are the same. Whatever it is, it's x. The third one is 9 inches shorter. So x minus 9. Okay. Now we know the whole thing is how much? 5 feet? So the first piece plus the second piece plus the third piece is going to be 5 feet. Now, I'm going to put this feet right here, and the reason why I want to put that there is, notice this is in inches, but this is in feet. I need to convert this 5 feet into inches. So remember, how many inches are in a foot? 12 inches. So this is going to be x plus x minus 9 equals 5 times 12 will be 60. Okay. Now I can go ahead and solve my problem. 1, 2, 3, that's 3x minus 9 equals 60. Let's just add 9 to both pieces. 3x equals 69. So when we divide by 3, x is going to be 23. So this piece is 23 inches, right? This piece is 23 inches. This is going to be 23 minus 9, which, let me grab my calculator again. 23 minus 9, I want to say maybe 14. Ah, there we go. 14 inches. And we found the lengths of each of those pieces. Okay. All right. So I'm going to continue working here, guys. And it says the sum of 2 consecutive terms in an arithmetic sequence, 1, 5, 9, 13, is 398. We want to find those 2 terms. Okay. Let's see if we can do this. Let's see what they're asking me to figure out. So number one, this is an arithmetic sequence. I know the first term is 1. D is the difference between the two. So 5 minus 1 is 4. 9 minus 5 is 4. There we go. Okay, so let me write out my formula. Remember my formula looks like this? Okay. So an equals 1 plus n minus 1 times d, which is 4. So an equals 1 plus, if I multiply this, 4n minus 4. So an equals 4n. If I have $1, but I owe you 4, minus 3. Okay. Now it says we're going to take two consecutive terms. What we mean by consecutive is one term and then the next one. So what I mean by that is the nth term I know is given by 4n minus 3. The n plus 1 term would be wherever I have the n, I'm going to replace it with an n plus 1 minus 3. Okay? So an plus 1 would be 4n plus 4 minus 3. So an plus 1 would be 4n plus 4 minus 3 is a plus 1. Okay? So this is one term, and this would be the next term. And it says the sum. Remember what the word sum means. Sum means to add. If we add two of them together, we're going to get 398. Okay? So what I'm going to do is I'm going to say if I take 4n minus 3 plus 4n plus 1, I'm going to come up with 398. 4n plus another n is an 8n. A minus 3 plus 1 is a minus 2. It's 398. So if I add 2 to both sides, I come up with 400, and I divide by 8, then n is equal to 50. Okay? So that means that the first term was 50, and the next one, n plus 1, would be 51. Now it's asking me to find those two terms, okay? So if this is an, so let's find the 50th term, okay? The 50th term would be 4 times 50 minus 3. 4 times 50 is, what is that, 200 minus 3? That would be 197, right? And then remember the next one, 51, is going to be if I add 4 more. So wouldn't that be, wouldn't that be if I add another 4 to it? Because that was the difference here. So 197 plus 4 should be 201. And if I were to take these two numbers and add them together, wouldn't we come up with 398? Yes, we would. So my two terms are 197. A50 is 197, and A51 was 201. There are my two terms. Okay. Alrighty. So let's take a look here. Next part we have is Matt has 4 times as many stickers as David. Okay? Matt has 4 times as many stickers as David. So let's see. How about if we say D if D is the number of stickers that David has, then 4D is going to be the number of stickers Matt has, right? Okay. Now it says that each of them have 75. Okay. So if they each have 75, then wouldn't the number of stickers that David has plus the number of stickers that Matt has, 75 plus another 75, so this would be 5D equals 150. So then if we divide both sides by 5, D should be equal to 30. right? And so if D equals 30, then Matt would have 4 times that, and 4 times 30 would be 120. And so if we add them together, that would give me my 150. Okay. All right. So let's take a look. The next problem here. It says, in a college, there are 16 times as many students as there are professors. Okay, so I'm going to read this part and I'm going to stop right there. I want us to think about that. There are 16 times as many students as professors. So what do we have more, students or professors? We got more students, right? So how about we say P, number of profs? So then 16P would be the number of students. Now it says together. What do I mean by together? The number of professors plus the number of students is going to be equal to 25,500. Remember, that's a 1P. So that's going to give me 17P equals 25,500. So now I can divide both sides by 17. Okay. And let me grab my calculator again. Turn it on. 25,500 divided by 17 is 1,500. Okay. So there are 1,500 professors. The question is asking us how many students are there. Okay. So I'm going to take that number 1,500 times 16 because we had 16 times as many students. Oh, let me get my calculator again. So now multiply it by 16. 24,000. And that's how many students we have. Okay. All right. So now, the next part talks about consecutive even numbers, okay? So I want you to think about consecutive even numbers. What I mean by that is, let's say the first number is 14. What's the number after that? Because it's consecutive even, it would be 16. The one after that, 18. The one after that, 20. Okay, what's the one before 14? Oh, it would be 12. What's the one before that? Oh, it would be 10. Okay, now I want to ask you, what did I do to get from here to here? I added 2. What did I do to get from here to here? I added 4, right? Okay. What did I do to get from here to here? I subtract 2. What did I do to get from here to here? I subtract 4, okay? So look what it says. The middle one is 4Q. This was kind of like my middle number, okay? So if my middle one is 4Q, okay, then the one after that would be 4Q. What did we do? We added 2. The next one would be 4Q plus 4, okay? The one before that was 4Q minus 2. The one before that was 4Q minus 4. Now it says the sum. So what does sum mean I'm going to do? I'm going to add. Okay? And it just says write the sum out. It doesn't tell me it's equal to a number. It's just telling me to write the sum out. Okay, so I want you to notice here. Minus 4 plus 4, they go away. Minus 2 plus 2, they go away. 1, 2, 3, 4, 5. That just gives me 20Q. Okay? Alrighty. So now, let's take a look at, I believe this is our last problem. It says in a geometric sequence, the first term is 9, and the fourth term is the square root of 6. Find the ratio. Okay. So my formula for the geometric sequence is going to look like this. Okay. So we know the first term is 9. Okay. We also know the fourth term is equal to the square root of 6. Okay. But the fourth term, if I were to use this formula right here, right? A4 would be equal to 9 times r to the power of 4 minus 1, right? Which would be equal to 9 to the times r to the power of 3. So that's just telling me that 9r to the third is equal to the square root of 6, because this one and this one are exactly the same, right? That's the fourth term. So what I need to do, I need to solve for r. Okay, we can do that. Let's divide by 9. Okay. And so now I have r to the third is equal to the square root of 6 over 9. Now, if you remember earlier when we had the square root, or we had r squared or x squared, we took the square root. Since we have to the third power, we're going to take what's called the cubic root. Okay. So I'm going to move my business here a little bit this way so I have some room. Okay. So cube root means I'm grouping in terms of 3. So I had 3 r's. I'm taking the cubic root. Now I just have r. Now, I'm going to show you what I'm going to do here. Remember, even though I don't see it here, this is the square root, right? What we do, guys, is we multiply those two together. 3 times 2, now I have the 6th root of 6. This is still the cubic root because there's nothing here, divided by the cubic root of 9. And there is my